Hi and a very good day. So in this video session I will show to you on how to fit the single exponential model by using CPI data, right? Okay, before we begin, because we actually have 5 different exponential model, so it is best for us to understand first, okay, the general model of each of these. Okay, as example here for single exponential model, okay, the general equation is ft plus 1. It means that the forecast value at time t plus 1, okay, the one step ahead forecast, okay, equals to alpha, the smoothing constant. Okay, it depends on how we choose the alpha value, times the past actual value yt, plus, okay, 1 minus alpha times, okay, the past forecast value. Okay, so this is actually the general equation. All right, okay, to start fitting the model, right, this is the step. Okay, first assume an initial smoothing. Okay, calculate the estimated. Okay, calculate the error, calculate NSE, and so on, right? But for this video session I will show to you by using Excel demo here, right? So we will use this data set from your textbook. Okay, so we have CPI data from 1960 until 1997, right? Let's imagine, because we use the textbook data set, we assume that we still does not have this particular value at 1998. That's why we say that we forecast this value. Okay, right, so so let's take a look at the step first. Okay, okay, so here we'll use, okay, the value of smoothing constant is use 0.9. So alpha here, it means that for this purpose of example I will use alpha equals to 0.9. all right, okay, this is actually best for us, okay, to put another table here for alpha. Okay, and I will show to you some tricks on how to easily calculate the single exponential smoothing. Okay, right, so here this is actually our historical data, or we say that this is actually our actual value y. All right, and based on the general equation, okay, based on the general equation, we say that for single exponential smoothing, okay, the general equation is ft plus 1 equals to alpha times yt plus 1 minus alpha times ft, right? But for the purpose of fitted value, okay, instead of f, okay, when we fitted the model, okay, so we will actually have okay, we will actually have fitted an estimated period as example. Okay, so for the purpose of this example, because we use the fitted value instead of f, okay, the equation will be, okay, yt plus 1. When we say that the fitted value, it means that the value came from the model. Okay, right, so the fitted value for single exponential smoothing is y hat t plus 1 equals to alpha times, okay, y, the actual value, t, plus, okay, 1 minus alpha times y hat t. Alright, so now we fitted the model at t equals to 1. So that's why, okay, y hat t plus 1 is, okay, 1 plus 1, 2, equals to alpha times y1 plus, okay, 1 minus alpha times y hat 1. Okay, so in this example, we will use alpha equals to 0.9, and we start fitted the model at t equals to 2. Okay, now the idea is, okay, when we want to start fitting the model, okay, we need this, okay, y hat 1, okay, or the initial value, right, the initial value. Okay, for the purpose of fitting the model, okay, the initial value, okay, we say that, okay, for the first initial value, y hat 1 is equals to y1. Okay, just for the initial value. That's why when we starting the model, okay, okay, this is y, the actual value, okay, this is y hat value based on fitted model. Okay, this is y hat 1, this is y1, so we say that the initial value is equal to 31.3, and then we fitted starting at t equals to 2, so we start here. Alright, okay, remember the basic equation is alpha times. So now, okay, for the purpose of modeling the single exponential, I just choose this column. Okay, that's why it is actually best for us to use Excel, because we can refer to the value, or we can refer to the cells. So here I refer to this cell J4, okay, and I need this value to be locked so that it not change, so I have to put $sign here. Alright, okay, times, okay, y1, okay, y1, okay, plus, okay, 1 minus, okay, I will use the same cell here. Alright, times y hat 1, right, and then you click enter. Okay, so this is actually the value for y hat 2. Okay, again, because we want to forecast this 1998 value, the idea is we, okay, drag until here. Alright, okay, so the idea is, okay, this is actually you want to focus here. Alright, so back to our discussion here. Okay, we actually want to focus f 1998 equals to alpha times, okay, y 1997, okay, plus 1 minus alpha times, okay, okay, right, times, okay, f 1997. Okay, for f 1997, we say that it is actually equals to y hat 1997. Okay, so here we just, by using the Excel spreadsheet, okay, we just drag, so you get the value. Okay, so for purpose of example, maybe you just need two, okay, you just need 2 decimal places. Alright, okay, alright, so this is the value. Okay, so this is the forecast value for alpha equals to 0.9. Alright, so how well this single exponential smoothing model when we use alpha equals to 0.9? That, okay, so to measure whether the method is best or not, okay, for this purpose we use what we call it as MSE, okay, mean square error. We calculate the difference between actual value and the fitted value, and we will see whether which alpha give the smallest MSE. Alright, so to calculate the MSE, okay, first you need another column here, okay, the ET, whereby the ET is the actual minus fitted. Okay, the actual minus fitted. Okay, so okay, minus fitted. Sorry, you need to make sure that you select the right cell. Okay, and then you just drag. Okay. Okay, so for MSE we calculate, okay, because we need actual value, so you can actually calculate up until 1997 only. Okay, so okay, again you can refer the MSE formula. Okay, you can refer the MSE formula okay, in this slide. Okay, MSE. Okay, MSE is equal to summation of the square of E over N. So means that we still need another column here. Okay, you just square root. Okay, right. Okay, so to calculate the MSE, okay, MSE, just simply as, okay, the average of, okay, you can actually use, okay, I use sum, okay, a sum of these, okay, over N. So how many observation we have? Okay, we have 38. Okay, right. Okay, so here we get the value of MSE is 8.656. Alright, so based on based on the value of alpha, if alpha 0.9, our MSE is 8.656. Okay, so that's the idea. Okay, what is alpha equals to 0.6 as example? Okay, because we already use this formula to get 0.6, you just simply change this value into 0.6, and then you will get the MSE. Okay, 17.441. What if you want 0.2? Okay, you just change this value and you get the MSE of 0.2. So which alpha give you the best single exponential model? Okay, choose based on which alpha give you the lowest MSE. Right, so for this video I think that's all. Okay, so this is your forecast value. Okay, so if you use 0.2, okay, this is actually your forecast value for 0.2, and then this is your this is your MSE, and okay, I think that's all for the first video demo, and I will explain another model in the next video session. Right, thank you for listening. If you have any question, you can reply under this post, or you can discuss with your respective lecturer. Okay, so thank you again. See you. Bye.